Welcome to the Asynchronous program talk. My name is Yifan. Here's a quick agenda of today's talk. It's funny, right? We're first going to introduce the difference between synchronous and asynchronous, and then we're going to talk about future and promise in Scala.concurrent. And then we're going to jump into Monix task, and then we're going to look at the similarities and differences between those two talks. And then we're going to talk about some of the best practices in debugging. So when we talk about concurrency, we usually look at those few words, synchronous, async, and then single-threaded, multi-threaded. So what do they really mean? What's the difference and similarities? And spoiler alert, I didn't dare to eat lunch before this because I'm afraid I'm going to burp when I give the talk. But right now, so I'm a little hungry right now. I'm going to use food as an example to show this. So as a thread yourself, if let's say in a synchronous single-threaded environment, what you're doing is, let's say we're cooking a meal. As a single thread, you will work on your first task, which is cook the omelet, and then you wait till it finishes before you move on and make the toast. And then you wait till it finishes, and then you move on to brew the coffee. In a synchronous multi-threaded environment, what's happening is yourself will cook the toast and then wait till it finishes. But at the same time, you have two wonderful friends that will come over and help you. So your wonderful friend one will make the toast and wait till it finishes, but at the same time, your wonderful friend two will brew the coffee and wait till it finishes. And in an asynchronous, single-threaded environment, what's happening is you prepare the egg, but you set a timer and say, let me know when this finishes, I will come back to it. And then you move on to make the toast and then set a timer, don't wait for it, and then you brew the coffee, set a timer. Now you have lots of time. You can sit down and read a newspaper. But remember that when you're reading the newspaper, you're not necessarily waiting for your task to finish, but rather you're executing something else. You're doing something else instead of waiting for the resources to finish. And then at the end, you collect the results. In asynchronous, multi-threaded environment, what's happening is you have, again, two wonderful friends that will come and help you, and yourself will prepare the egg, set a timer. At the same time, your wonderful friend one will also make the toast and set a timer. And then at the same time, your friend two will brew the coffee, set a timer. Now, you guys have all the time in the world. You can sit down and play board games together. And now when things are done, you collect the result and have breakfast. So asynchronous sounds amazing, right? How do we achieve that in Scala? We can use the Scala.concurrent package. There are future and promise. We're going to talk about those. So what is a future? You can think of it as a container that contains value that might come back in the future. And future is immutable. We say that if the computation inside the future has not been completed yet, we say that the future is incomplete. But if the computation has been completed, there are two possibilities. Either the future completed with a success. In this case, it comes back with a value. The other case would be it comes back with an exception, and that will give us a failure. So how you use future, you can use this to register callbacks, for example. You can use onComplete to register callbacks on your future. So what you do here in your onComplete, you first pass in a higher-order function that takes in a try, returns something else. Also, you pass in an execution context. You can think of this as something that helps you to manage your threads, and this wraps around fork join pull. So how you use this is you first create a future, you do some calculation in the future, you create the future by putting those inside the future block, the bricks, and then you produce a future. And then you can call onComplete on this future that you just created. And then you can specify, in the case of a success, I'm going to do something, for example, process the results. And then in the case of a failure, you can say, I'm going to log it, or I'm going to return it, do whatever you need. This will allow you to register callbacks. You can call onComplete on the same future multiple times. However, there's no guarantee that the callbacks will be called in the same order as you wrote it down. So your callbacks will be triggered once your future is completed. So you're not necessarily waiting for the futures to finish before working on something else. And you can also use and then in future, which is kind of similar to onComplete, but the difference is that you're allowed to chain the callbacks together. So in this example, you create a future, and then what you do is you, in the first and then, you specify a case where, in this case, you want to do something, and then you can chain them together by calling another and then on top of the and then you just called on the future. So and then will allow you to register callbacks in a specific order. So those will also be triggered in a specific order. So the interesting thing in and then is it doesn't propagate the exception that's thrown in the cases. For example, if you create a future and then the future, let's say, it completed successfully, but in the first and then case, there's an exception thrown. And in the future, if you chain another and then on top of this, what happens is that the second case and then will use the successful value from the future instead of propagating the exception thrown in the first case. So when we're using and then, we need to be cautious of how we handle the exceptions and how do we not miss it. You can also transform your future by using this transform function. And what you do is you pass two higher order functions. One is, what do I do when future completed with a success? And the other one specifies, what do I do if the future completed with a throwable? You also will need the execution context. How you use it is you first create a future by wrapping some calculations in the future, and then you can call transform on the future you just created. In the first clause, you can say, in the case of a success, I'm going to get some data, and this is how I will process my data in the first clause. And then the second clause, you handle what do I do if I got a throwable. So in this case, you can put whatever you need to do in this clause to specify what you want it to do after the future is completed with a failure. So in Scala 2.12, if you notice, there is something quite similar. It's also transform. When I was looking at this, I was thinking, why do I need two transform in one library, and what's the difference and what are the similarities? Well, the straightforward answer is that this one is more generic and flexible. So let's take a look at how. In this one, again, you create a future. Let's assume that this time the future completed with an exception. And you can use this transform, but instead of passing in two clauses, you can pass in one higher order function that says, what do I do when there's basically from a try to another try. So what do I do when there's a success? In this case, I can return something that's a try. And then in the case of a failure, now I don't have to throw a throwable. What I can do here is I can pretend that I completed this future with a success. So I can return a success. So this transform doesn't force you to give a throwable when your future completed with a failure. So it gives you more power. But more power always comes with great responsibilities. So when you're using this transform, just be cautious of what it can do. And we're going to come back to recover and fall back to if we have more time. Now let's talk about promise. You can think of a promise as a writable single assignment container. So if you think of future and promise, you can think of it as a pipe. So future is the part where you take your data out, so you have read access. But your promise is the side where you push data in, so you have the write access. So with a promise, you can create a future. You can also complete the future inside of the promise, but only once. So you can complete a promise by calling complete. And how you use it is you first create a promise, and then you have reference to the future of the promise by calling p.future. Then you can register some callbacks telling it what to do after your future is being completed. After that, you're saying, OK, I'm ready. I'm going to complete this promise. Now, when you first call complete, you're fine. But then second time, if you try to call complete on the same promise, you will get an illegal state exception because you can only complete your promise once. So what if you say, I don't want an exception because I can't remember how many times I've completed the promise. Like what if, I just don't remember. And what if I don't want an exception? That's fine. You can use this try complete function where this will return you a Boolean instead of an exception when you complete it multiple times. So what you can do here is you can create a promise and then have reference to the future by calling p.future, register callbacks, and now let's say you've completed once. And the second time when you try to complete the same promise, if you call try complete, instead of throwing you an exception, it will just simply return you a false. So if you're uncertain about whether you've completed the promise before or not, and you don't want an exception thrown, it's, you can use this try complete method to complete your promise. If it completed it successfully, then you will just get a true instead. So we've been looking at future and promise for a while, and I'm sure you all ready for a quiz. So let's say we're building a client-facing interface, and I'm going to walk you through this code. Let's say we first, in the function, we create a promise. And then we're going to wrap some tasks, some very complex and time-consuming task in the future. And then at the end of the task, at the end of this future block, we say, now we're done. We're going to complete our promise. And then outside of this future block, we're going to return the promise. So raise your hand if you think there's something wrong with this code. OK, a few. Anyone wants to try to explain what's wrong with this? Sorry, why? So he said you want to return p.future. Why? But if they have the promise, they can still read from it. They can still. Exactly. So that's exactly right. So, well, there's always something wrong with the examples, right? So that's definitely the right reason. So we said the future is writable. And by giving this future to your user, you don't really know what they are going to do with your promise. So you're giving them the right access to your promise. But most of the cases, maybe we'll only want the user to read instead of writing to what we have. Because right now in this code, we are completing the promise inside our future. But since future is asynchronous, your function won't necessarily wait for whatever is inside of your future to finish before moving on. So by the time you return this promise, your future might be still working. And by the time, let's say if your user completed your promise before you, now when you try to complete this promise at the end, if you call p.success, you might get an exception because maybe your user has already completed it. So you don't want that to happen. Instead, you need to return the future, which gave them the read access so that they can register callbacks instead of writing to your promise. And let's talk about Monix task. So what is Monix? Monix, it helps you to write asynchronous and event-based programs. We're going to focus on Monix task today simply. Monix is a lot more powerful than what I will talk about, but if you're interested, feel free to look into the library. You can think of Monix as a factory of future instances. So it creates future. And because of that, Monix, you can determine whether you want it to be lazily evaluated or eagerly evaluated. So in task, here what you can do is you can create a task and call run async. Let's take a look at this example. Well, OK, so if you use run async, you need to pass in the scheduler, which is quite similar to the execution context. It extends the execution context. When you first create the task, you can simply call task and then put a chunk of code inside there to create this asynchronous task. And then now, at the moment when you created this task, your task will not be evaluated. But later, if you call run async, this is when your task is evaluated. And this will produce you a cancelable future. What if you say, I want my task to be like future, where it can be evaluated eagerly? That's fine. You can do this with run on complete, where this one, it works something very similar to like futures on complete function. How it works is you first, again, create a task, and then you call run on complete on the task that you just created, and then you can pass in what do I want to do when it completed with a success, and then also tell it about what I want it to do when in the case of a failure. This task will be evaluated eagerly, and this run on complete works very similarly to futures on complete. So when you create the task, you can determine whether you want it to be evaluated eagerly or lazily. So if you call task.now and then you pass a chunk of code inside, you will get a task that is evaluated eagerly. And if you call task.defer and then you put a chunk of something that gets evaluated eagerly, this will produce you a task that is evaluated lazily instead. So in Monix, you can also determine whether I want this to be memoized by default or not. So for example, you can create a task by calling task.eval, and this will create a task that will be evaluated lazily, and also it will not memoize the results, so it won't cache your results when you evaluate it. Every single time when you call run async, this will reevaluate your task and then produce the same side effect. So this offers referential transparency, whereas if you call eval once to create a task, this will memoize your task. So it will only evaluate your task once and then cache the result. In the future, if you call run async again on the same task, it won't give you any side effects because it won't never ever evaluate your task again because you asked it to memoize your results when you first evaluated it. And there's a really cool function here called memoize on success. So let's say you have a program that randomly throw exceptions and you don't know when it's going to throw exception, but you only want the successful result. You can use this memoize on success. So you have this chunk of code that produces exception when the value generated is odd, else it will just return the even number. So in this, when you create the task, when you call memoize on success, this task will only cache the result if the result is a success. So in this example, the first time and second time when we run async, it will yield the exception. Because of that, we don't really cache, we don't memorize the results. But then the third time, if it completed with a success, then it will choose to memorize the result. And in the future, it will just return you the same number because it's been memoized. And you can also override the thread pool on your task by calling execute on. And how this works is you can create your thread pool by calling scheduler.io, passing the name of the thread pool. And you can create a task, and then on top of the task, if you call execute on with the given thread pool, you will be able to create another task with the specified thread pool that you asked it to use. So now if you call run async, this will use the threads from the given thread pool that you provided. But Monix task is immutable. So if you try to call execute on twice on the same task, then it will simply ignore everything after the first time you call execute on. So because it's not mutable, so it will only look at the first time you've modified the thread pool. So it will only use the threads from the first thread pool. It will simply ignore the second execute on. Also, Monix produce cancelable future, so that means you're allowed to cancel your future. How it works is you can, again, create a task, and then let's say you're not sure whether you don't want to execute this task immediately when you call run async. If you say delay execution, give it a time period. When in the future, if you change your mind saying that I kind of don't want the result anymore, so if you call cancelable future dot cancel, so when you call run async, it's going to delay the execution, right? And then it will produce a cancelable future. But now, if you change your mind, you can say dot cancel, this will cancel the future, so it won't return you the result of the future. You can also call it multiple times, but it will just produce the same effect. So what are the similarities and differences between future and Monix? So future is a value, and it will be executed and evaluated when you first create it. But Monix is a function, right? We say that it produces futures. So because of that, you can kind of decide whether you want it to be executed lazily or eagerly. And future, you will need the execution context whenever you create the future because it's evaluated eagerly. But for Monix task, you can provide the scheduler whenever you call run async because run async is when you actually evaluate the task. For memoization, future by default is memoized, but Monix task is not memoized by default. But you can, again, specify whether you want it to be memoized or not. And for error handling, so we talked about that in some callbacks, it doesn't always propagate your exception to the future clauses. So we kind of, as developers, we don't really want our failures to be swollen because it could help us to debug in the future. In this case, we want to see our exceptions. So you can do this in both future and task by overriding the report failure method in the execution context. And you can also provide a customized logging tool to log your log your failures. So to convert a future to Monix task, you can simply create a future, and then if you call task.fromFuture and pass in the future that you just created, this will create you an eagerly evaluated task. So let's say if you want something that's lazily evaluated, you can just simply wrap this thing inside task.defer. So this will create you a task from future, and the task is lazily evaluated. From Monix to future, you can call run async on task because we said task, if we call run async, it produces cancelable future, and cancelable future extends future, so it's technically a future. Oh, let's talk about debugging asynchronous code. It's going to be fun. So debugging asynchronous code is extremely painful, right? But we have to face it every day. So what are the good practices? Coming back to the breakfast example, if we have so many threads and so many people trying to cook the same thing at the same time, it could possibly create a mess. So that's called too many chefs in the kitchen spoil the broth. Yes, I said it right. And we don't want this to happen, so how do we avoid this? Well, to avoid bugs, the best thing is not to write any bugs, but if you have to debug, right? If you have to debug, so when you find yourself that you have to add more code to your bug, to your code to fix something, well, you probably need to step back a little because when you're trying to add something to fix something, sometimes it means that you're creating more bugs. So when you find yourself trying to add more code to fix something, it's the best to step back and rethink about it. Rethink about your design, rethink about what do you want it to do, and then proceed. When it comes to testing asynchronous code, what you can do is you can pull out your chunks of code and put them in isolation. So create an environment in which you completely understand what's going on and inject synchronous walls into your code if you need, and then observe what's happening with your async code. Make sure it produces the exact result that you expect it to before moving on to testing another chunk. So we're going to look at some examples. Let's say, let's say we're using again the breakfast example, we can simply call await.result to ask it to produce the thing inside the future. So in this given example, let's say, we're cooking breakfast in futures. So we cook the omelet, it produces a future, and then we do toast and coffee, and then we have a very complicated function that uses a forward comprehension and put all the futures inside and produces a future of breakfast. So in reality, this can be much more complicated. So how we really know what's going on, one way to do it is you can call await.result, the second to last line, and then you can pass in your future inside await.result. Also specify a timeout time. In this case, it's 1 second. So that means I'm willing to wait for the result to come back at most 1 second. And this at most timeout time can be either a positive number or it can be a negative number. When it comes to a negative number, that means you're not willing to wait at all. And you can also give it a duration.inf, standing for infinite. So you're willing to, for as long as it takes. So at the end, the await.result will produces the thing that's inside the future, and then you can print it and see if it's exactly what you expect it to be. If the future did not complete after this timeout time, you will get a timeout exception when using await.result. For testing future, you can use Scala test. In Scala futures, you can use this when ready thing. So if you call when ready and pass in your future inside of this function, and then in the brace, you can specify what do I expect inside of this future. So you can say, this should be something. And then this when ready if it failed, it will give you the test failure exception. Also, you can override the timeout time. So the default timeout is 150 milliseconds, and you can override it by giving another timeout time. Is there any better way than print lines? Yes, there are debuggers. So there are two great debuggers. One developed by Julian is called the async debugger, and the other one is in IntelliJ. It's called Capture. Because of time, I can't go through all of those resources, but those are links in my slides. I'm happy to post my slides on Twitter later. You're happy to read through them. And let's talk about how async debugger really works. So if you set breakpoints in your async code, what happens is that it will replace your the stack trace where your async code is executed with the stack trace where your async code is called. So this secretly has a global map that has keys, which are identifiers, mapped to stack traces that are values. And they will just send messages, and the identifiers will be the message. So the sender of the identifier would be the code where the async code got executed, and then the receiver will be where the async code is. So the downside of this debugger is that you have to specify the exact signature. That means you need to give the exact name of the class, exact name of the method, exact name of the parameters, and everything. So when it comes to debugging, it's pretty difficult. So I was asking around. I was like, does anyone know how to debug asynchronous code well? And I was asking Alex, the author of Monix, expert, how to debug asynchronous code. And Alex said, well, I think right now people mostly use print lines and breakpoints because there's not really a good way in general to debug it. But we hope that we will at least come with a decent solution in the future. So I kind of believe right now we don't really have a great, elegant way to debug our asynchronous code yet. But as a community, we can think of something, and then it would be great if we can put those ideas together and help, in general, the tech community, not just the Scala community, to come up with some tool that help us to debug asynchronous code to make our life less painful when it comes to debugging async code. And on top of that concludes my talk. Thank you for paying attention for the last, 29 minutes, so I'm right on time. Thank you, and enjoy the rest of the conference and beer. And also, please come to me if you know what's the difference between those three. I'm just really confused. Thank you, and also, please come to me if you have questions. I'm happy to answer them. Thank you.